All right, guys. So in this video, we're going to be looking at section 1-6, which is called special functions. The first type of special function we're going to look at, and the primary one today, is going to be what's called a piecewise function. Basically what a piecewise function is, it is a function made up of pieces of other functions. So you have a whole bunch of different pieces to it that are all going to have their own little section of the graph. So they look a little bit different than other types of functions that we've seen so far. First thing I want to make sure we understand how to do is how to evaluate a piecewise function. So we're going to do a little bit of practice with that first. In this example, we're going to have f of x, which is made up of negative 2x minus 2, the number 3, and the negative 2x plus 6, and each of those will be in a different section of the graph. So let's say for this first example, we want to evaluate f of 2. I need to figure out where does 2 fit into those intervals that are over there on the right side. And keep in mind, 2 is the x value that I'm plugging into my function. So what I'm doing is checking to see which interval does it fit into. Does 2 in fact mean that it's less than or equal to 1? Nope, that doesn't work. Does 2 fit as a number between 1 and 3? And yes, it does. What that means is I would plug 2 in for x into that middle expression, but there's nowhere to plug x in. Instead, I'm just going to write the number that's there and say that f of 2 is equal to 3. Next, let's go ahead and evaluate it for f of negative 3. So again, we're trying to figure out where does negative 3 fit as an x value first. I'm going to first check, does negative 3 make this first inequality true? Is negative 3 really less than or equal to 1? Which it is. So what I'm going to do is take negative 3 and plug it in for x into that first equation. So I'm going to say negative 2 multiplied by negative 3 minus 2. And then I'm going to evaluate that. So negative 2 multiplied by negative 3 is 6. 6 minus 2 is 4. So f of negative 3 is going to be equal to 4. And then let's go and take a look at this last one. I'm looking for f of 3. So I'm trying to figure out where does 3 fit as an x value into one of those sections over there on the right. Is 3 a number which is less than or equal to 1? And the answer is no. Does 3 fit as a number between 1 and 3? And I have to be careful here because notice that this second half of the inequality just says greater than. It does not say greater than or equal to. So is 3 really less than 3? And the answer is no, it's not. So how about this last section? Is 3 a number which is greater than or equal to itself? And the answer here is yes, because of that equals bar. That 3 is equal to 3, so it does work in this last equation. So that's going to be where I'll plug 3 in. So I'll take negative 2 multiplied by 3 plus 6. Negative 2 times 3 is negative 6. And negative 6 plus 6 is 0. So I can say that f of 3 is going to be equal to 0. So that's a little bit about how to evaluate piecewise functions. Next, let's go ahead and take a look at how to graph them. So for our first example, we're going to graph the following piecewise function. H of x is going to be equal to negative 3x plus 2, as well as 1/2 x minus 4. So the first section of the graph I'm going to create is this first piece of my graph, the negative 3x plus 2, and it tells me the x values need to be less than or equal to 2. Easiest way I found to do this is to just simply make a table, and then for the x values, we're going to pick out numbers that are less than or equal to 2. So we're going to start with 2, and then we're going to pick out numbers that are less than or equal to that, like 1, 0, and negative 1. And then what we're going to do is we're going to start to plug those numbers in to get my y values. So for the first one, I'll take negative 3 multiplied by 2 plus 2, and then figure out what that's going to be equal to. So that would be negative 6 plus 2 is going to be equal to negative 4. And then I'll go ahead and do the same thing, plugging 1 in for x. So negative 3 times 1 plus 2, that's going to be negative 1 plus, or negative 3 plus 2, which is going to equal negative 1. Then I'll go ahead and plug 0 in for x. So negative 3 times 0 plus 2 is going to multiply to be 0 plus 2, which is just going to be equal to 2. And then last but not least, I'll plug negative 1 in for x. So negative 3 times negative 1 plus 2. Negative 3 times negative 1 is 3, and 3 plus 2 is going to be 5. So when I go to graph this, the first thing I want to make sure of is that I'm using the correct type of point to start. Since it's less than or equal to, I'm going to use a solid point to include that number at 2. So what I'm going to do is go to that first point, which we figured out was 2 comma negative 4. And I'm going to start there with a closed point right on top of that value. Then I'll go ahead and plot 1, negative 1. First, I need to make sure this point's in the right place. I had it at negative 2, negative 4. Let's fix that. Here is positive 2, negative 4. Then I have 1, negative 1. And then I have 0, comma 2. And then negative 1, comma 5. And you can probably see where these points are headed. From that first point, they are going up and to the left. So what I'm going to do is simply connect those points going up and to the left as best I can. And then here's going to be the first piece of my piecewise graph. Next, what I'm going to do is the exact same thing with the second part of this function. So the second part says 1/2 x minus 4. And this time I want for my x values to be greater than 2. Even though 2 is not greater than itself, we just talked about it, we're still going to start with 2, and then we're going to find other numbers that are greater than 2 for my other x values. So I'm just going to pick numbers again like 3, 4, and 5. So then I'm going to start plugging those numbers into my equation. So I'm going to have 1/2 times 2 minus 4 for this first one. Half of 2 is 1, and 1 minus 4 is negative 3. Next, I'll plug 3 in for x, so 1/2 times 3 minus 4. This is where it would be okay if you wanted to go ahead and use a calculator. 3 times 1/2 is 1.5, and then 1.5 minus 4 is going to be negative 2.5. If you really don't like the decimals, since we know we're going to be taking half of numbers, it might be best to pick even numbers that are greater than 2. So instead of 2, 3, 4, 5, I guess I could have probably used 2, 4, 6, and 8. That might have been a little bit better way to have done this, but since I've already started it this way, I'll go ahead and finish it. So my next one shouldn't be too bad because 4 is an even number. I'm going to take half of 4 minus 4, which half of 4 is 2. 2 minus 4 is negative 2. There's going to be my next y value. And then I'll do that one more time here with 5. So 1/2 of 5 minus 4. So half of 5 is 2.5. And then 2.5 minus 4 is negative 1.5. And then I should be ready to graph this other piece of my piecewise graph. Now, once again, when I start to graph these points, I need to be careful about what type of point I'm going to start with. This time, since it is just a greater than sign without the equals to, I'm going to use an open point here. So what I'm going to start with is at 2 comma negative 3. I'm going to put an open point here at that value. And then I'll go ahead and graph 3 comma negative 2.5. So halfway right here. Then I'll go to 4, negative 2. So that would be this point right here. And then last, I'll be at 5 and negative 1.5 right here. And then I can simply connect those points, which are this time going up and to the right. And then here would be the second piece of my piecewise graph. Notice that this is still a function because it does still pass vertical line test. Even if you were to try to draw your vertical line through those 2 points that look like they're overlapping, keep in mind it's only going to cross through one point. The other point is an open point, so it doesn't count as a point. So it does still pass the vertical line test and still does count as a function. Okay, let's take a look at one more together, and then you guys will have a chance to try one for yourself. So for this next graph, I'm going to start by graphing this first part of my equation, which says 4. And it tells me x is greater than or equal to negative 2. So I'm going to start by building my table once again, using negative 2 as my starting point. And then I want numbers that are less than or equal to negative 2. So numbers like negative 3, negative 4, negative 5, and so on. Now, for this one, notice there's not anywhere to plug x in. All I'm going to get is the number 4. In fact, for every single one of these x values, all I'm going to get is that same y value, which means that the table goes pretty quick and it shouldn't be too hard to graph. So I'm going to start with my first point being a closed point because once again, it is a less than or equal to sign. So at negative 2 comma 4, I'm going to start with a closed point. And then negative 3 comma 4 would be right here, negative 4, 4, and negative 5, 4. And then really what this is going to look like is just a horizontal line going over and to the left. Next, let's go ahead and graph our next section of this piecewise graph. So I've got x squared with -2 less than x less than 2. So for this particular table, it's actually telling me what numbers for x I want to be between. It wants me to start my table at -2 and then go all the way up until I get to 2. So it gives me a point to start with and also a point to end with. For each of those, I'm going to be squaring the number. So I'm going to take the first number, which is -2, and square it, which -2 squared is +4. Then I'll take -1 and square it. -1 squared is 1. Next, I'll take 0 and square it. 0 squared is 0. And then continue with 1 and 2. 1 squared is 1. And 2 squared is equal to 4. Now for this section, since it's a less than sign for both of my two parts of my interval, I'm going to be using open points at the beginning and end of this piece of my graph. So what that means is my first point, which is at -2, 4, I'm going to put an open point there. And it actually just so happens there's a closed point. So really on your paper, unless you're using colors like mine, you're not going to be able to see that there's an open point there because there's already a closed one. Next, I'll have a point here at -1, 1, another point at 0, 0, a point at 1, 1, and then once again at +2, 4, I'm going to have to use an open point there because, again, it was just less than. And then connecting those points, I'm going to have kind of a U-shaped piece of my graph here in the middle, which is going to look something kind of like this. All right, for the last section of my graph, it's going to be very similar actually to the first section. It says that it's going to equal 4 when x is greater than or equal to 2. So once again, I'm going to start with the number in my interval. So if x has to be greater than or equal to 2, I'm going to start with 2 and then pick out numbers which are greater than or equal to it, like 3, 4, and 5. And like the first one, there's nowhere to plug x in. All I know is that it's going to equal 4 no matter what. So 2, 4, 3, 4, 4, 4, and 5, 4. So graphing that piece of my piecewise graph, I'm going to be using a solid point here because it does say greater than or equal to. And so at 2, 4, we already had an open point. Now we're actually putting a closed point there as well. So once again, on your paper, unless you're using different colors or really making your open point big around your closed point, probably not going to see it. Then I'll have points at 3, 4, 4, 4, and 5, 4. And then it's just going to, just like the right half, kind of be a horizontal line going out into the right. So then here is what our piecewise graphs should look like. I think it's time for you guys to try one. So at the top of the next page, there is a try it for you guys. What I'd like for you to do is go ahead and pause the video, go ahead and work through that try it. And when you're ready to check your work, go ahead and press play. All right, let's see how you did. So we're going to take this function piece by piece, just like we have the others. We'll start with this first piece, which says 1, and it tells us that 0 is less than or equal to x, which is less than 1. So when I'm making my table for this, I actually know the numbers I'm going to use. I'm going to start with 0, go to 1, and that's it, because it goes from 0 to 1. And I know for both of those, it's going to give me +1. So 0 goes to 1. 1 goes to 1, and then notice that it is less than or equal to on the left, so closed point first, and then just less than for the second, so open point second. So I'm going to start with my closed point over here on the graph at 0, 1. I'm then going to put an open point here at 1, 1, and then connecting those, I'm just going to get a very small piece of my graph, which is a straight line in between them. Then for my next section of the graph, I'm going to end up doing something very similar. I'm going to build my table. It tells me that the x values need to go from 1 to 2. So here is 1 and 2. This time, my y values are all going to be the number 2. And then similar to the last section of my graph, notice it's less than or equal to, so a solid point, and then less than, so an open point. So at 1, 2, I'm going to put a solid point here, which ends up being right above that open point that I just graphed. I'm then going to put an open point over here at 2, 2, and then connect those with a straight line. Next, I'm going to go ahead and build my third section of the graph. So with my third section, once again, I'm going to have my table down below. I'm going to start with 2 as my first x value, 3 as my second x value, and then notice that these are all going to come out as the number 3. And once again, I'm going to start with a closed point because less than or equal to, end with an open point because of the less than sign. So I'm going to end up with 2, 3, a closed point right above my open point, an open point here at 3, 3, and then a real small piece, this line segment here, in between. At this point, I'm hoping that you're seeing a pattern. I'm hoping that you're seeing that it's kind of the same, just going up and to the right. In fact, if you didn't even want to build the tables for those last 2 sections, you could go ahead and finish the rest of this graph with those last 2 sections. Essentially, it's a closed point to begin with, an open point then, and then coloring in that line in between. And then one more time here, closed point, going over by 1 to an open point. And so here would be my graph. Once again, notice that it is in fact a function. In fact, some of you who did the activities last week would recognize this as one of the graphs that you did see. Notice that if I try to draw a vertical line through it, it's only going to cross through once if I go through the middle. And if I do try to cross through at the ends, it's only going to cross through the solid point, not the open point. So it does in fact still make a function. In fact, this is a special type of function in and of itself. So not only is it a piecewise function, it's also what we call a step function. So a step function is a special type of piecewise function whose pieces are line segments in a stair-step pattern. So what we just saw was an example of what we'd call a step function. There is one other type of special function that I would like for us to talk about today, which is what's called an absolute value function. An absolute value function looks like this: f of x equals the absolute value of x. What an absolute value function is going to look like is it's going to have a V shape to it. Easy way to remember that is it's called absolute value. Value starts with the letter V, so anytime you see a V-shaped graph, that's going to be absolute value. There's also going to be a special point for absolute value functions, which is what is called the vertex. The vertex is the turning point of the graph. We've talked about other types of turning points like relative maximums and minimums. A vertex would be a relative max or min depending on what the graph looked like. And so that'll be an important point to kind of keep in mind and make sure that we can see on our graphs. So we're going to look at a couple examples of absolute value functions. We're going to graph each of these below. And then also it does want us to state the domain and range. So we'll make sure to do that at the end. So for our first function, f of x equals the absolute value of 3/4 x plus 3. So first what we need to do is build a table for this function. So I'm going to make my xy table here, and then I'm going to start picking out numbers for x. I want to pick both positive and negative numbers, so I might first try to go from -2 up to 2. Those are usually pretty good numbers to start with. I think what might be even better though is if you look at the fraction that we have, we're going to be essentially dividing by 4. So what might be better for us to do is pick out multiples of 4 rather than just counting by 1. In other words, instead of going 0, 1, 2, maybe we go 0, 4, 8, and then do the same thing going in the negative direction, use -4 and -8. And then let's go ahead and start plugging those into our absolute value function. So we're going to take 3/4 multiplied by -8 and then plus 3. So first thing that we would want to do is multiply 3/4 by -8. So what that's going to be, I'm going to multiply -8 by my numerator. I'm going to have 3 times -8 is -24/4, all inside those absolute value signs, and then plus 3. Then I can simplify that fraction. -24/4 is going to be -6. So I have the absolute value of -6 plus 3. The absolute value of -6 is just +6. So remember, absolute value is just the distance from 0. It will always come out a positive number, whether it starts positive or starts negative. So the absolute value of -6 is just +6. And then 6 plus 3 is going to equal 9. Next, we'll go ahead and plug -4 in for x. So we'll take 3/4 multiplied by -4 and then plus 3. For this one, we can do a little bit of simplifying before we actually multiply. because if I'm multiplying and dividing by 4, those are just going to cancel each other out. I'm still going to have the negative sign, so negative multiplied by 3 would be a -3. So I've got the absolute value of -3 plus 3. The absolute value of -3 is 3, and 3 plus 3 would be 6. Next, let's plug 0 in for x, so we'll have 3/4 multiplied by 0 plus 3. Well, the nice part is 0 times 3/4, that's all just 0. And then I don't have anything to take the absolute value of, so really all I have left is the plus 3. So it looks like that'll just be my answer here. Next, I'll go ahead and plug 4 in for x, so I'll take 3/4 multiplied by 4 inside the absolute value signs plus 3. Here, once again, I can cancel out my 4s. There's not even a negative to worry about this time, so now I just have the absolute value of 3 plus 3. Absolute value of 3 is still 3, and 3 plus 3 is 6, so there's going to be my next number. And then last, I'm going to plug in 8 for x, so 3/4 multiplied by 8 plus 3. And then I can multiply 3 times 8 is 24, so I've got 24 over 4 inside my absolute value signs plus 3. 24 over 4 reduces to be 6, so I've got the absolute value of 6 plus 3. And the absolute value of 6 is just 6 plus 3 would equal 9. And now we should be ready to graph. So I'm going to start with my point, -8, 9. So I'm going to go to the left by 8, up by 9. Here's going to be my first point. Next, I'll go to -4, 6. So -4 to the left and then up by 6. Next, I'll be at 0, 3. So that'll be this point right here. Then I'll go out to +4, 6, which would be this point right here. And last, I'll go to 8, 9, which would be this point right here. And then I can simply connect those points. And here would be my absolute value graph. So notice that it's got that V shape that we would kind of expect from an absolute value graph. We can also now see clearly where the vertex is. You can see the vertex where our graph turns is going to be this point at 0, 3. So just to make sure we understand the vocabulary, that is what we refer to as the vertex. All right, let's look at one more example of absolute value, and then that'll be it for this section. For the next one, we've got f of x equals -2 times the absolute value of x plus 1. So once again, we're going to build a table for this. I'm going to start my table x and y, and then I'll start picking out numbers for x. Once again, we might try to start with numbers like -2, -1, 0, 1, and 2. And then let's just see if those will work. Notice that there's not a fraction or any numbers being multiplied by x inside the absolute value signs. So really, it shouldn't matter what numbers we use. So let's just stick with these and kind of see what we come up with. So for -2, when I plug -2 in for x, I'm going to have -2 multiplied by the absolute value of -2 plus 1. That's going to be equal to -2 times the absolute value of -1. And then remember, the absolute value is going to make that -1 a +1. So if I take -2 times 1, that's just going to be -2. Next, I'll go ahead and plug -1 in for x. So I'll have -2 times the absolute value of -1 plus 1. So that'll become -2 times the absolute value of 0. Well, that's going to be 0 inside the absolute value signs. And if I take that and multiply with -2, that's still going to just be 0. So it looks like 0 is going to be my y value there. Next, I'll go ahead and plug 0 in for x. So -2 times the absolute value of 0 plus 1, which is going to be -2 times the absolute value of 1. Well, the absolute value of 1 is just 1. And if I multiply that with -2, that's just going to be -2. Next, I'll go ahead and plug 1 in for x. So -2 times the absolute value of 1 plus 1, which is going to be -2 times the absolute value of 2. Well, the absolute value of 2 is just 2, and 2 times -2 is going to be -4. And then last, we'll go ahead and plug in 2 for x, so -2 times the absolute value of 2 plus 1 is going to be equal to negative 2 times the absolute value of 3. And the absolute value of 3 is 3 times that negative 2 in front is negative 6. And now we should be ready to graph it. So it looks like my first point that I came up with was at negative 2 comma negative 2. So that's going to be this point right here on my graph. Next was negative 1 comma 0. So that's going to be this point here. Next, I had 0, which came out to be negative 2. So that's going to be this point right here. At 1, I have negative 4, which would be right here. And last, I have 2 comma negative 6, which would be this point right here. So then we can see where this graph is going. It's actually opening down this time. Looks something kind of like this. So even though it doesn't open up, it still kind of has a V shape to it. And once again, we can see where that vertex is. In this case, that vertex ended up being at the ordered pair negative 1, 0. And that is it for absolute value. And that is it for this section of the notes. Until next time, guys, have a great day.